Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, so we will continue on 4.5 hypothesis test for the difference between two population mean, okay, specifically for independent sample. Okay, if you still remember at 4.4 we already look into hypothesis testing for one population mean. Okay, so we have three different cases, okay, to solve the hypothesis testing for one population mean. Okay, whereas for under this topic for independent sample, okay, if you still remember at estimation topic, we have four different cases. Okay, so let's take a look into the first one, okay, which is when the population variance are known. Okay, so we have two population here, sigma 1 square and sigma 2 square. Okay, so the test or the hypothesis that we want to test is at the null hypothesis we have mu1 minus mu0 equals to 0. Okay, or other than that you can write as mu1 equals mu2. Okay, and then at the alternative hypothesis we have mu1 minus mu2 less than 0, or mu1 minus mu2 greater than 0, or mu1 minus mu2 not equals to 0, meaning that we have left tail test, right tail test, and two tail test. Okay, so the assumption for the case number 1, which is for the population variance known, we have population are normal, both population are normal, the sample are independent for each others. So the test statistic that we will use is z equals to x bar 1 minus x bar 2 minus d. So d is the difference if you are given if the value as stated in the equation, whereas other than that, if they are not mentioned in the equation, we will put d equals to 0. Okay, meaning that, okay, what are the value that you have defined here? Okay, maksudnya the difference between population 1 and population 2, ada apa value difference dia? Kalau tak ada, kita letak kosong lah. Okay, so z equals to x bar 1 minus x bar 2 minus d over square root sigma 1 square over n1 plus sigma 2 square over n2. Okay, let's take a look into example 4.13. To measure a population in a home, let's x and y equal the amount of suspended particulate matter measured during 24-hour period in a home which there is no smoker and a home which there is a smoker. Okay, so kita define x and y kita adalah, so we have population x, population y. Population x is referring to the home with no smoker, and population y is referring to the home which there is a smoker. Okay, so assume that the distribution of x and y are, okay, untuk x has normal distribution with mean x and variance 64, and for y it has normal distribution with mu y and variance 36. Okay, so this is where we define, we know the population variance. Okay, for x, this one is for x and this one for y. Maksudnya this information is referring to the population, not a sample. Okay, we want to test whether there is a higher amount of suspended particulate matter in a home with smoker than without smoker. Okay, so apa yang kita nak test adalah, okay, let's me highlight this word, whether there is a higher amount of suspended particulate matter in a home with smoker than without smoker, meaning that apa yang kita nak test adalah y, okay, adakah mu y, okay, mu y is greater than mu x. With home with a smoker is greater or higher than home without smoker. Okay, so we have a random sample of size 9, okay, for X, which is a home with no smoker. X bar we have 93 and S or standard deviation 12.4, while a random sample of 11 yielded Y bar equals to 130 and SY equals to 7.2. Test at 5% significant level. Okay, so memang dia bagi kat sini, okay, kat sini variance untuk population 64 and variance untuk population Y 36. Dia bagi juga value standard deviation untuk sample 12.4, 7.2. So awak jangan tersilap. So kita tak perlulah nak guna value standard deviation untuk sample ni, sebab kita dah tahu value population. Saya tengok formula kat sini, sigma 1 square, which is variance for the population. So yang ni kita tak akan guna value untuk sample ni. Okay, dia just bagi to make you confused lah, nak guna yang dia bagi ataupun value sample. Okay, so the first step is construct your H0 and H1. So our first step, what is your H0 and H1? Tadi saya dah define. Kita nak tengok tadi adalah higher amount of suspended particulate matter in home with smoker than without smoker, meaning that Y greater than X. Okay, so we can write the null hypothesis as mu Y minus mu X equals to 0 versus mu Y minus mu X more than 0. Okay, alternatively you also can write as, okay, mu Y equals to mu X or mu Y more than mu X. Tak ada masalah, boleh. Both you can write salah satulah. Okay, our second step is write the test statistic. So our test statistic are Z. Follow this formula. Okay, so the test statistic are Z equals to, okay, since kita buat Y tolak X, so meaning that X2 minus X1 lah. Okay, Y tolak X. Tengok awak define dekat H0 H1 awak apa, Y tolak X ke X tolak Y? Boleh juga, tak ada masalah. Alternatively, yang ni kita nak test home with smoker greater than without smoker. Kalau awak nak buat without smoker, tolak smoker pun boleh, tak ada masalah, tapi sign dia akan bertukar lah. Mu X minus mu Y less than 0. So that's why you have to be careful in constructing the H0 and H1. Okay, so since saya buat Y tolak X, so meaning that we will write as Y tolak X lah. So Y bar tolak X bar, 130 minus 93, okay, minus 0, sebab kita tak define any value kat sini, that's why we put 0. Okay, over square root variance sigma 1 square over n1, so meaning that 64 over untuk Y kita ada 64 over 9 plus 36 over 11. And then we will get the answer as 11.482. Okay, then step number 3, calculate the critical value. So lupa lagi nak tulis. Okay, kat sini tadi we should write as this one is right tail test. Okay, so the critical value is Z alpha lah, so we don't have to divide the alpha by 2 because our sign here is greater or right tail test. Okay, so we will write as Z alpha. So our alpha is 0.05. So refer to your table, you will get the critical value is 1.6449. Okay, then we will decide on what are the decision rule. So since this was a right tail test, so I will shade it the right at the right side. Okay, let's say the critical value here is 1.6449. So our test statistic we get 11.482. okay, which is false in the rejection region. So don't forget, first kita tulis dahulu what are the decision rule. So we will reject H0 if test statistic greater than critical value. So we can see here our test statistic is 11.482, which is greater than 1.6449. So our decision is reject the null hypothesis. Okay, reject H0 since 11.482 is greater than 1.6449. So what can we decide here? So the conclusion is, so since we reject the null hypothesis, meaning that we accept the H1. So meaning that we can say that there is a higher amount of suspended particulate matter in a home with smoker than without smoker. So meaning that mu y greater than mu x. Okay, settle case number 1. Now we look into case number 2, which is sigma 1 and sigma 2 square are not known, but both sample size are 30 or more. Okay, so then the test statistic will become this: x bar 1 minus x bar 2 minus d over s1 square over n1 plus s2 square over n2. So if you realize, the difference is only at this formula. Case yang pertama tadi dia sigma, kita tahu population variance. This one we does not know the population variance or population standard deviation, so that's why we replace by S, meaning that we should take the value of the sample. Tapi syarat dia and dia mesti 30 or more. Okay, mesti besar, large lah. So look at example 4.14. Okay, so saya nak you complete example 4.14. Dia sama step dia, ada 5 step tu, cumanya dia berbeza dari segi yang kat bawah ni lah. Dari sigma dia menjadi S. Okay, so please try example 4.14. Okay, let's continue case number 3. Okay, case number 3. Okay, we will look into when the population variance are not known. Okay, unknown. So kita kata sigma 1 square does not equal sigma 2 square. Dia kita tak tahu, tapi we assume that it was not equal for population 1 and population 2. So what are the assumption? Okay, the assumption are populations are normal or small sample. Okay, untuk case number 3 ni, kalau case number 1 and number 2, number 1 we know the population variance for both population lah. Okay, case number 2 we does not know the population variance, but the sample size are large. Okay, now case number 3. Case number 3 pula, the population are normal, but the sample size are small, meaning that it was less than 30. So the standard deviation are not known, but we assume the standard deviation are difference. So the test statistic that will be used here, so untuk case number 3 dengan case number 4 kita akan start guna T. So untuk case number 3, untuk unequal variance, okay, formula dia adalah T equals to x bar 1 minus x bar 2 minus D over S1 square over N1 plus S2 square over N2. But we need to find the value of degree of freedom. Okay, if you still remember the formula at estimation topic, so formula of the degree of freedom is 1 square over N1 plus S2 square over N2 square over S1 square over N1 square divided by N1 minus 1 plus S2 square over N2 square over N2 square N2 minus 1. Okay, but you need to truncate the degree of freedom value to the lower value. Okay, meaning that if, for example, if you get 2.6, let's say, so meaning that the degree of freedom is equivalent to 2. Or you get the value, the DF value equals to 10.7, so meaning that you need to truncate the value into 10. Okay, look at example 4.15. The breaking strength of 11 bundle of wool fiber have a sample mean 436.5 and sample standard deviation 11.9. In addition, the breaking strength of another 12 bundle of synthetic fiber have the sample mean 452.8 and a sample standard deviation of 4.61. Assume the breaking strength of the two populations are normally distributed with unequal variance. Okay, so awak kena baca dengan berhati-hati maklumat yang diberi supaya awak tidak tersilap menggunakan formula lah. Okay, so we want to test at 5% level of significance whether the mean breaking strength for the wool fiber is less than of synthetic fiber. Okay, so this is the question, whether the mean breaking strength of wool fiber less than synthetic fiber. Okay, wool less than synthetic. Okay, so kita ada maklumat untuk wool fiber. We have N equals to 11, sample mean 436.5, sample standard deviation 11.9. Okay, so this one is NW untuk wool. Okay, X bar untuk wool dengan sample standard deviation S untuk W. Okay, another one is for synthetic. So we have 12 synthetic fiber. Sample mean 452.8. Sample standard deviation 4.61. So this one is N untuk synthetic, X bar untuk synthetic, and S synthetic. Okay, so let's solve this example. First step is construct the H0 and H1. Okay, so the null hypothesis is we want to test the mean breaking strength for wool fiber is less than synthetic fiber. Okay, so we can write as mu W minus mu S equals to 0, or mu W equals to mu S versus mu wool minus mu synthetic less than 0, or mu wool fiber less than mu synthetic. So salah satu je lah awak nak buat macam ni ataupun like this. Okay, yang kedua, calculate the test statistic. Okay, so our test statistic tadi adalah T. So T equals to X bar W tolak S, kita buat since kita buat W tolak S. So X bar untuk W wool is 436.5 minus 452.8 tolak dengan kosong, kita tak define any difference here, over 11.9 square over 11 plus 4.61 square over 12. Don't forget to square root. So we get the T equals to negative 4.2594. Okay. So kat sini awak kena faham lah, kalau awak buat S tolak W, synthetic tolak wool fiber, awak akan dapat value ni positif lah sebab besar tolak kecil kan. So tak ada masalah how you awak nak buat population 1 tolak population 2 ke, population 2 tolak population 1, tak ada masalah. Janji simbol dia kena betul. Yang ni kita nak buat W less than S. Kalau awak nak buat S tolak W, so dia akan jadi S greater than W. Okay, yang ketiga is the critical value. So our critical value adalah T alpha. Alpha kita adalah 0.05, and then you need to calculate the degree of freedom first. So degree of freedom for this question, kalau awak tengok dekat chapter depan ni, kita dah buat the same example actually. Okay, so the degree of freedom, cara nak calculate dia, formula yang panjang tadi tu lah, S1 square over N1 plus S2 square over N2 square, dan seterusnya tu kan. Okay, saya tulis dekat bawah ni lah, tak muat lah. So df equals to 11.9 square over 11 plus 4.61 square over 12. Okay, kuasa 2 bahagi dengan 11.9 kuasa 2 bahagi dengan 11 tambah 4.61 square over 12. Okay, ini bahagi dengan 10, this one bagi 11. So finally we will get here is 12.721. Then we will truncate, dia akan menjadi 12. So meaning that kat sini degree of freedom dia, sorry, so degree of freedom here is T 0.05, 12. Okay, so look at your table T, we will get 1.782, but don't forget to put negative sign here because our sign here is less than. This one, lupa nak tulis, this is left tail test. Okay, then step number 4, write your decision rule. Okay, so the decision rule, kalau kita lukis, kita akan fokus on the left side lah. Okay, so this one is the critical value. The critical value here is negative 1.782. So then we will reject when the test statistic value falls in this rejection region. Okay, now look at your test statistic value. We get the value of negative 4.2594, which is false in the rejection region. So meaning that we can write the decision rule as reject hash not if the test statistic less than negative critical value. So what are our decision here? Step number 5. We will reject hash not. Reject hash not since negative 4.2594 is less than negative 1.782. So what can we conclude here? There is significant evidence to indicate that the mean breaking strength for wool fiber is less than synthetic fiber. Okay, now I want you to complete example 4.16. Okay, menggunakan kaedah yang sama lah untuk example 4.15. I will give you the answer later on. Okay, so please complete previous example also, 4.14 and then now 4.16. Okay, for example 4.17 also, I want you to complete this example also. Okay, but for this example, you are given the Minitab output. Okay, so answer all these questions based on the output given to you. Okay, you need to state the hash not and h1, show that the test statistic 9.91. Okay, and then make the conclusion. Okay, so please do first this example. Okay, now let's take a look into case number 4, which is population variance are not known, but we assume there were equal variance. Okay, for both population. So what are the assumptions? So the assumption are population are normal and small sample. Standard deviation, sigma 1 and sigma 2 are not known, but okay, we assume it was equal. Okay, kalau tadi not equal, they're small, both are small, less than 30, but we assume not equal. So this one we assume equal. So the test statistic will be T equals to x bar 1 minus x bar 2 minus different over pool standard deviation SP times square root 1 over n1 plus 1 over n2, where the value of the formula for pool standard deviation equals to n1 minus 1 s1 square plus n2 minus 1 s2 square over n1 plus n2 minus 2. Okay, kalau tadi kita kena cari degree of freedom, yang ni yang awak kena cari adalah dia punya pool standard deviation. So example 4.81, an insurance company want to know if the average speed at which man drive car is greater than woman driver. Okay, yang ni dia nak test average speed man driver greater than woman driver. Okay, so dia punya statement dia nak test mu untuk man greater than mu untuk women. Okay, so they took the sample of 26 car driver by men. Okay, and found that the mean speed 72 miles per hour, standard deviation 2.2 miles per hour. Okay, so kita ada value NW, kita ada N untuk men. N untuk men equals to 26. X bar untuk men equals to 72 miles per hour. And S untuk men equals to 2.2. Okay, untuk women pula. Women, we have sample of 16. Okay, and mean speed of 68 miles per hour and standard deviation 2.5. Okay, so dia punya N untuk women equals to 16. X bar untuk women equals to 68. S untuk women equals to 2.5. Okay. And then another information here. Assume that the speed at which all men and all women drive car on this highway are both normally distributed with the same population standard deviation. Same population standard deviation, meaning that we assume the population sigma 1 equals to sigma 2. So we want to test at 2.5 significant level. Okay, whether the average speed man drive car greater than woman driver. So as usual, our first step is you need to construct first the H0 and H1. So kita nak buat mu untuk man driver, mu W man M tolak woman equals to 0. Okay, versus man minus woman more than 0. Okay, ataupun boleh buat mu M equals to mu W versus mu M greater than mu W. So this one is right tail lah. So step number 2, find the test statistic. So our test statistic adalah T. So T equals to X bar. But jangan lupa kena cari SP dulu ya. So kita cari SP dulu. Full standard deviation dia adalah N1 minus 1, 26 tolak 1, N1 minus 1 S1 square 2.2 plus 16 minus 1 times 2.5 square over 26 plus 16 minus 2 square root. So we will get the pool value is 2.317. Then we can calculate the T. So T is X bar 1 minus X bar 2. Men tolak woman. 72 minus 68 minus 0 over, okay, SP tadi 2.317 darab dengan 1 over 26 plus 1 over 16. Okay, finally we get the T is 5.433. Now step number 3 is calculate the critical value. So the critical value are T alpha. Alpha here is 0.025. Degree of freedom, okay, kalau ada dua population, degree of freedom dia adalah N1 plus N2 minus 2. So 26 plus 16 minus 2 is equivalent to 40. So look at your table T, you will get the critical value is 1.684. So from here we can decide on the decision rule. So you need to draw your region, your acceptance region and rejection region. So this one is right tail test. So here 1.684. So we will reject hash naught if the test statistic falls in the rejection region, or if the test statistic value is greater than 1.684. So reject hash naught if test statistic greater than the critical value. So we can decide here, we are reject hash naught because since 5.433 is more than 1.684, so we can conclude that there is significant evidence that the average speed at which men drive car is greater than women driver. Maksudnya kita accept claim H1 lah, sebab since kita reject H0. Okay, so we accept the H1. So H1 tadi kita dah tulis average speed by man driver is more than woman driver. So please write your decision. Don't forget, after you decide, write your conclusion. Okay, so for example 4.19 and also 4.20, please solve by your own. I will give you the working later on. Okay, so this one is case number 4 lah, specifically for case number 4, and you are given the Minitab output. Okay, so kat sini ada information on brand 1 and brand 2. Okay, dia ada bagi kat awak full standard deviation pun dia dah bagi kat sini, SP. This one is SP 4.7434. Okay, so you just terus gunalah, masukkan. Okay, so soalan A dia tanya write the H0 and H1. What are the distribution is used for the test and why? So sama ada guna Z atau T. Kita bagi tahu sebab dia kenapa. Kalau guna Z kenapa, kalau guna T kenapa. So untuk this case guna T lah, sebab this one is under case number 4. Okay, and then list out the assumption. D. Okay, kalau output dia ada bagi p-value, so it is advisable for you to use the p-value approach. Kalau guna p-value, we just the decision rule is only one. We compare alpha and with the p-value. Okay, we will reject H0 if the p-value less than alpha. Satu je dia punya rules. Tengok awak punya p-value, compare dengan alpha. If the p-value less than alpha, then we will reject the null hypothesis. Okay, and then question E. Okay, based on your decision on at D, so you can answer question E lah. Okay, so ingat kalau guna p-value approach, alpha dia tak perlu bahagi 2, walaupun alternatif awak adalah two-tail test. Kalau guna p-value tak perlu bahagi 2 dia punya alpha. Kalau guna p-value, but kalau guna test statistik biasa yang compare test statistik dengan critical value, then baru awak tengok alpha tu kalau two-tail kena bahagi 2. Okay, so here I have summarized. Okay, untuk hypothesis test for the difference between two population mean of independent samples. So we have 4 cases here. First, we have population variance known. Okay, so please digest all these steps. Okay, yang membezakan dia adalah dekat test statistik dia. Okay, so remember we have 3 types of hypothesis that we can write, either left tail, right tail or two tail. And then yang paling obvious kena takut silap adalah dekat sini lah. Kalau dekat two tail, alpha kena bahagi 2. Same goes to case number 2, but case number 2 is for population variance unknown, both sample size are large and 1 and 2 greater than 30. So just focus on dia punya test statistik dia. Kat sini still Z, tak beza pun dengan case number 1, cuma beza dia satu ni sigma, satu ni S. Kalau tersilap pun dia tak ada efek yang sangat besar lah. Okay, again dekat two tail, alpha kena bahagi 2. Okay, untuk case number 4, case number 3, we have population variance unknown, but we assume it does not equal. Dan satu lagi, there's small sample lah, less than 30. Okay, observe at the test statistic, how we calculate the test statistic. Yang ni kalau unequal, kita kena calculate the degree of freedom. Formula dia panjang sikit. Again, satu kena hati-hati, kalau dekat two tail, alpha mesti bahagi 2. Okay, kalau left tail, kena letak negatif lah. Right tail, tak perlu letak negatif. Two tail, kena ada plus, minus, but it will consider 2 rejection region at left side and the right side. Okay, biasanya, okay, kalau perasan lah, kalau awak buat less than, which is left tail, dia punya test statistik dia mesti akan dapat negative value, sebab biasanya kecil tolak besar. Okay, that's why critical value pun kena letak value negatif. Sebab tadi kita buat dekat left tail kan, so dia kena letak negatif. Tapi kebiasaannya lah, kalau test statistik negatif, mesti dia, biasanya kita buat dia referring to the left tail. Okay, that's why critical value kena letak negatif most of the time, macam tu. Kalau left tail, mesti dapat negatif. Okay, untuk case number 4, population variance unknown, but we assume equal. Okay, so case number 3 dengan case number 4, we use T. Okay, but case number 1 and case number 2, we use Z. Okay, untuk case number 4, kena calculate dulu full standard deviation. N1 minus 1 S1 square plus N2 minus 1 S2 square over N1 plus N2 minus 2. Don't forget to square root, because we will use this value in order to calculate the test statistic. Kat bawah ni kena guna SP. So kena cari dulu SP. Tapi kalau dekat dalam minute output, biasanya dia dah bagi siap-siap lah. Unless kalau soalan tu tanya find the full standard deviation. Okay, so again kat sini kena hati-hati value. Kalau kat two tail, alpha kena bahagi 2. Left tail ada negatif. Okay, right tail positif. Two tail, it will consider plus and minus value, positive and negative value. Okay, kalau dia bagi p value, kalau soalan kata using p value, so you need to use the p value lah, p value approach. The rules on only one. Reject hash not if p value less than alpha. Tak kisahlah left tail ke, left tail, right tail or two tail. Kalau guna p value, satu je punya rule. Reject hash not if p value less than alpha. Tak perlu bagi 2 walaupun two tail alpha tu, just compare terus p value dengan alpha. Okay.